question. In fact, there was a question that came in through the chat on, is there a way to convert bodies into components? So I'm going to go ahead and actually answer that one live right now. So if you accidentally created something as a body instead of as a component. Um, and the reason this question came up is in part one, I talked a lot about the difference between bodies and components and why you should always try and create everything as components. But in this case, I created this box as a body. Yes, you can right mouse click on this bodies folder and you can see create components from bodies. And now this is a component, which I can now, um, do things with like add joints or whatever. So yes, if you accidentally create something as a body, you can convert it if necessary. Okay, so let me get started here. Today's session, I'm going to be talking more about the assembly menu. So we're going to be talking about a lot of these commands in here, such as the joint command, as-built joints, rigid groups, tangent relationships, etc. Kind of gonna go through kind of at a high level, trying to hit the key points about each of these things. Um, like I mentioned last week, we talked about what are components. So hopefully you were able to attend last week. So I'm not going to be talking about that. So the first command in here is joint. And so when I run this command, what is a joint basically? Why do we create them? And you'll notice when I run the command, I get this menu that comes up. And basically what a joint is you're trying to lock down degrees of freedom. So for example, if I just grab this component right here, you can notice I can move it around. I can move it up and down, left and right, forward and back. I could rotate it in the X, Y, and Z axis. So there's like 6 degrees of freedom that this thing could move around. And in reality, we want these things locked down. So for example, this is going to be like bolted to a bench, for example. And then this component here is going to rotate around this ring. So we want it to have a degree of rotation, for example, but we don't want it to move up and down. We don't want it to rotate left and right or whatever. We just want it to spin in 1 degree of rotation. And that's what the joint command allows us to do, is to create different types of joints. So for example, you're going to see these different types. So we have rigid joints that locks down all 6 degrees of freedom. It's like we've welded these two parts together. They can't rotate, they can't translate. Then we have revolute. That opens up 1 degree of revolution. So it can rotate around a particular axis, whether that's the X, Y, or Z axis, for example. Then we have slider. So instead of revolving, it's going to slide. So you can think of that as like a translational. So it can slide or move in 1 degree. So for example, this jaw is going to slide through this other jaw in 1 degree of translation. And then we have some more advanced ones, such as like cylindrical. So that allows it to rotate and slide. So it's 2 degrees of freedom. So it can slide and rotate. Pin slot is exactly kind of what it sounds like. It's like it allows it to move inside of a slot, like a pin inside of a slot, for example. Um, so it allows it to rotate and slide. And then planar, you can kind of think, I think of it like almost like a hockey puck on ice. So it's it can move in the X and Y direction, but you don't want it to move up or down or rotate. And then we have the ball joint, which is kind of like a tripod head. So it opens up 3 degrees of rotation, right? So it can move in all different directions of rotation, but it can't translate. And these will make more sense as we go through, but these are the different types of motion types in the joints. And then you'll notice it has component one and component two. And so we're going to basically say we're going to move one component to another component and create a joint to do that. So let's go ahead and kind of show how this is going to work. So I've got a bunch of parts kind of just randomly located on my screen. And you can kind of think of this as the bottom up design methodology that I talked about last week, where you have a bunch of different parts and you bring them into almost like an assembly session or assembly mode. You bring them in and you start assembling them together. And that's kind of what I'm doing here. So the first thing I need to do is all of these parts can move freely with each other, right? Well, I need to pin one in place. I need to basically tell Fusion which one can't move. And I'm going to use this one here. If I click on it, I just clicked on the face, it highlights that that one's called base. And so I'm going to right mouse click on it in the browser, and you can see one of the options is pin. And when I do that, it puts a little pin icon on it. And now if I try and click and drag on it, you can see that I can't move it. I can move these other parts, but I can't move that one. And so now I can start adding my joints to that. So I'm going to go ahead and create the joint command. And it's asking for a snap. And so I'm going to kind of basically, I want to put this part on top of this part here. So I'm just going to find, or actually I should say underneath it, I'm going to find like an edge, for example, like either this edge here or this edge here. And you'll notice when I hover over them, I get this little icon that kind of appears right here. And this is what's called a joint origin. And depending on where I hover on a face or whatever, you're going to see that joint origin appear in different locations. And I can select where I want to capture from. So for example, I could capture the center of this screw hole if I wanted to. But in this case, I'm just going to grab this edge and it's going to capture the center of that edge, and it's going to capture the plane of that edge. So what do I mean by that? Well, watch what happens when I move up to this edge. Notice how that cursor, that joint origin moved up. And then if I come down here, you can see how it's a little bit lower. So it's basically putting that joint origin on the center of this edge and the plane of that edge. So I'm just going to go ahead and click there. And then I want that to basically line up with like this edge right here. And it's kind of the same thing. You can see depending on where I click, it's going to find the center of that edge and it's going to select that plane also. And we can see how it brought that ring over, and it's called, I guess it's called the swivel, and it brought it over and it lined up those two joint origins in the exact same location. Now, it doesn't look like it really did much. It's just sitting there. I'm going to come over to my motion type, and my motion type is rigid. In fact, if I hit this little preview, you can kind of see it shaking. It's basically saying we've glued, welded, press fit, or whatever these two parts together. They're rigid with each other. Well, I don't want them to be. I want that to be able to rotate. So I'm going to come in here and open up 1 degree of freedom. I want it to be able to revolve. So I'm going to click on revolute, and you can see how the preview shows it revolving around, in this case, the Z-axis. Okay, now I could come in here, this won't make much sense, but if I hit the X-axis, you can see how it's going to revolve around the X-axis or the Y-axis, but obviously in this case, we want it to be in the Z-axis. I'll go ahead and say okay, and if I click and drag on this component now, you can see how it is sitting exactly where I told it to be, and it can rotate in that Z-axis direction. Okay, so let me do the same thing with this. Now, we're going to see an issue here. I'm going to just click and drag this body right here, and we can see a whole bunch of components don't move with it. That's because there's a whole bunch of components here, but they don't have any joint relationships with this other body. So I'm going to hit this revert position. you'll notice those icons don't exist, but as soon as I move something, they appear. And one of them is capture position and one is revert position. And I actually use revert position, 90% of the time. So I'm just gonna hit revert position and it puts it back. Now, what I'm going to do here is we're going to kind of jump ahead a little bit and we're going to use this as built joint. And we're also going to use this rigid group command. Okay. So there, when I move this, I can see some of these pieces, like for example, this ruler, and it even has these little rivets that were kind of modeled in place. So I don't want those to change. I want them to kind of stay stuck to the body. So I'm going to come in here and say rigid group. And this is a really simple command. It just says, what are the components? So I'm going to click on the ruler, these two little rivets. Let me grab this other rivet and this body. And I'm just going to go ahead and say okay. And now notice when I move the body that that ruler and those rivets are rigid. They're rigidly grouped with that body. So it's a really great way to kind of group things together. And I didn't have to create a joint command for each of those objects. In fact, we can kind of see back here, there's like this back casing with a couple bolts and stuff like that. I'm going to do the exact same thing. I'm going to come in here and just say rigid group. Let's say that guy, I'll click on that bolt there, and the body. I'll say okay. And now when I move that, that whole assembly kind of moves together as a rigid group. And all that's left are these little levers here. Okay, so the rigid group command is a very, very useful command, especially for things like I just showed, where you don't need to create a revolute joint or slider joint or something. It's, they're stuck to the object. They have to move with it, like the back part and the ruler, etc. Now these guys, they have movement. They can rotate, they can slide, all that kind of stuff. So I'm going to use the as-built joint. Now, why am I using as-built joint instead of the joint command? Well, as-built joint is used when the objects are already where they need to be, which you can see they are. They're already where they need to be. They're already on this object. They're already assembled together. So I'm going to use as-built joint. And again, pretty simple. It's asking what are the components and then what's the motion type. Well, I'm going to come in here and I'm going to do a slider. And I'm going to say this component and this component. Okay. Now it's asking select a snap point to define the joint origin. So it's asking for like a direction for the arm to slide along. And it's kind of hard to see the icon, but you can kind of see these two little lines. I'm just going to click on this shaft right here. And when I click on that, you can kind of see a preview and how that's kind of going back and forth. I'm going to go ahead and say okay. And I just created a slider joint between this object and this object. Then I'm going to do the exact same thing. I'm going to come in here and say as built joint. And I'm going to say this time let's do a revolute. And I'll say between that object and that object, what's my snap? Well, I want it to revolve basically around this cylinder. So I'm just going to get near either that edge or this edge. It really doesn't matter. I'm going to go ahead and click, and you can kind of see it gives me a little bit of a preview of that spinning around, and I'll say okay. Now, if I try grabbing this and moving it, we see a potential issue. This thing, the whole thing is moving around, and it's not simulating it sliding or revolving. And that is because remember the very first thing we did was we pinned the base in place. We told it, hey, you can't move. You're bolted or welded or whatever to the table. Well, this doesn't know that. This is floating out in space. So let's go ahead and click on that. That's the body. I'm going to go ahead and pin the body in place temporarily. And you can see it has a little pin icon on it now. And if I, oops, let's see if it'll let me Oh, I'm sorry, I need to do this guy. Let me pin this guy in place. Okay, yeah, so now I can't drag that guy. And if I grab this handle now, you can see how it can slide and rotate at the same time. Now you'll notice it's also rotating into the body because I haven't set up any limits or anything like that, but you can quickly see how we were able to create as-built joints that simulate the sliding and the rotation of these two components very quickly. Okay. So same thing here. I mean, I'll show you how quick this is. I'm just going to say as-built joint. We'll do a revolute. I'll say that guy and that guy revolves around that. I'll say okay. I'll repeat that last command. I'll say that guy and that guy revolves around that. Repeat my last command. Let's do a slider. That guy and that guy. I'll say okay. And now you can kind of see how that works together there. And I'll do a as-built slider between here and here. Say okay. And oops, make sure I grab the component there. And you can see how we can slide and rotate at the same time. And so I didn't have to create a bunch of different joints like I did over here where I had to pick a from and a to and all that kind of stuff. I literally was able to build, you know, using the as-built joints because they're already created. The objects were already assembled where they needed to be. I'm going to go ahead and unpin this because I'm done with that. And now when I move this body, because all of these joints exist, they all move together. So I used rigid groups to move a lot of the parts together rigidly. And then I used as-built joints to assemble some of the moving components of, you can almost think of this as like a subassembly. So now I'll use the joint command. I'll come in here and say, let's create a joint. I'm just going to click on like that edge there. And let's just say this edge here. And you can see it's doing a revolute, but then you see this weird thing happen, okay? All these parts are floating out here in space. And you're like, well, you just spent a bunch of time, moving, adding all of these rigid groups and all kind of stuff. How come they didn't move? And the answer is actually right here. We're only dealing with two components at a time. The one we want to move, and this is actually a little phrase I came up with to help me remember, which one do we want to move and where do we want to move it to? Well, the one I wanted to move was this guy. And where did I want to move it to? I wanted to move it to the base down here. As soon as I say okay, all of these other components know that they have to be over here and they'll move in place. As soon as I say okay, there they are. And you can see I can now rotate that base. I'm going to undo that and do that one more time so you can kind of see what I did there. So I'm going to say joint. Which component, which one do I want to move? I want to move this one. So I just click on that edge. Where do I want to move it to? I want to move it to this part down here. And I'm just clicking a cylinder or a circular edge, and you can kind of see that little icon right there in the middle. Okay, and I'm going to zoom out so you can kind of see what's going to happen here. I click, and that guy moves, and it gives me a preview because it remembers my last motion type that I did was a revolute. Let's just say it was a rigid. I would just have to come in here to the motion tab and select revolute. Gives me a nice little preview. Yep, that's what I expect it to do. I say okay, and now we have this assembled like so. And then I can just continue doing this. I'm just going to say joint. I'll just go ahead and select a circular edge. I'll select a circular edge. That guy moves in place. And in here, you can rotate it, but maybe in this case, I'm going to say I want that to be rigid. I'll say okay. And now that moves with the body. This guy here, I want that to be a slider. So I'm going to come in here and say assemble. And um, I'll just go ahead and maybe select like maybe like this edge here with this edge here. Now it remembers my last motion type as rigid. I'll come in here and say slider, and it gives me kind of a weird preview. And again, it doesn't do anything with like limits or anything like that. But then I'll go ahead and say okay. And now I can slide this back and forth. I can rotate this whole unit together. And there you go. You can see how quickly we were able to assemble this whole thing together using joints. And that's kind of the idea behind the joint command is you're locking down all degrees of freedom and then opening up the 1 degree, like the slider or the revolute or cylindrical or whatever for 2 degrees of freedom, for example. Hopefully that makes sense. Again, if you have any questions, feel free to post them into the Q&A as we're going through. I have quite a few topics I want to cover, so I'm kind of going through at a pretty accelerated pace. So again, any questions, feel free to post them out there for us. Okay, I already showed as-built joints, but I really want to show the power behind as-built joints. And this is actually an assembly I brought in from McMaster Car. So I just came in here, went to McMaster Car, and I just did a search for a toggle clamp. So I just, typed in toggle clamp, and you can see all of these different types of toggle clamps in here. So I just clicked on a hold down toggle clamp, and I just picked one randomly out of here, and this is what I get. And this will actually answer the question. I can't remember. Oh, I actually already converted them. They come in as bodies. I just right mouse clicked and said convert bodies into components. And you can see that they're now components. And they have no assembly structure whatsoever. However, it's already assembled, right? They're already in the correct location. So this guy here, I went ahead and pinned it in place. You can kind of see that little pin icon. So I can't move this base right here. And I'm just going to use the as-built joint. So I'm going to say as-built joint. And most of these are revolute joints. So I'm going to change this to revolute and check out how quick this is. I'm going to say this part revolves around this part. And I just have to find a cylindrical or circular edge. So I could click on, like, for example, this face, or I could click on like any of these edges. So I'm going to click on that edge there and just say, okay. And now this handle rotates around that pin. Okay. So I'm going to continue with that. I'm just going to say as built joint. I know that this part and this part revolves around that guy. I know this part and this part revolves around this guy, and this part and this part revolve around this guy. So just that quickly, I've now kind of built how all of these parts work together. Now, obviously we see some issues here, like the plastic handle and this assembly over here, but just notice how quickly we actually are simulating how this handle and this clamp work together. Okay, so how would I get this plastic part to move with this guy? Well, that's where rigid group comes into play. I want this guy and this guy to be rigid with each other. So I just say, okay, and now they're rigid with each other. It's that quick. Same thing with this. These are all individual components. You can almost think of this as almost like a sub-assembly. So I'm going to come in here and say rigid group. I'm just going to click all of these components. And now if I grab one of them, they all move together. Okay. Let's go ahead and do an as-built joint. And I'm going to say this guy and this guy. Well, I want them not to revolve, but slide. And so I'm just going to pick on like an edge. I want like this washer to kind of slide along like this edge right here, and you can kind of see a nice little preview. In fact, if I hit this preview motion, you can kind of see what that looks like. Now, of course, it's not moving all of the other components. It's only doing a preview of one of them. And then you'll also notice I have in this dialog, I have this joint motion limits, minimum, maximum, and rest. So this is kind of cool. I'm going to turn on minimum, and you can kind of see this little flag. And I could move this around. So I could say, maybe that's the minimum I want to be right there. The maximum, I'll bring it over here somewhere, like so. And then I could say rest, and that's this little icon right here. I could say maybe I want it to be somewhere kind of in the middle. And I'm just going to go ahead and say okay. And what I just basically did was I told it what the minimum and maximum movement that this slider joint can do. So if I were to grab this, you can see even though I'm continuing to move my cursor to the right, it can't go any further than that. And if I let go, it's going to go back to that rest position. And if I drag to the left, it can't go any further to the left because that was the maximum and the minimum, for example. So you can kind of see that's as far as it can go. And if I let go, it's always going to return to that resting position. That's what let me edit this guy so you can kind of see that again. That's what the minimum, maximum, and rest positions are. And now I just randomly picked some in here, but yeah, you could come in here and type in, 0. I could make this, just 0.6, for example. Um, set that to be a specific number, and we can set this to be like 0.4 or whatever. You can make it whatever you want. And so, um, but I like using the little sliders. Okay, so now I created a slider joint. This is a rigid group. So now when I grab this handle here, you can see that that all works together. And this is using that as-built joint. I didn't have to create, a regular joint where I had to say, what's the origin point, pick an origin point, and then pick, another point for it to go to, like you do with the regular joint command. Because it was already assembled, I just said, you know, this guy and this guy revolve around an edge or an object or something like that. Pretty cool command. In fact, I'll be honest, the as-built joint is probably one of my favorite commands in Fusion. I just think it's so powerful. I mean, I literally could bring in any assembly from another CAD tool, whether it's SolidWorks or Creo or an IGES file from GrabCAD or whatever. I mean, it could be anything. I could bring it into Fusion and if it's already assembled, I just use the as-built joint command, boom, boom, boom. I can simulate how it works. In fact, you're going to see a lot of that today with different assemblies. Okay, here's another example of where as-built joints and rigid groups come into play. So here's a file I brought in from GrabCAD. Okay, and this is what it looked like. Now, these are all individual components, right? With no relationships or anything. So but it's already assembled, right? So I'm gonna come in here and say as-built joint. I'm gonna change this to Revolute. I'm gonna say this part revolves around that pin. And I'm just gonna click on that circular edge right there and it gives me a nice preview. I'll do that again, as-built joint, this part and this part revolve around that edge right there. And now if I grab this little hinge panel, you can see how it revolves around that hinge pin, but we see the issue with the screws. Okay. Now I could create, as-built joints or whatever for each of these screws, but that would take, 6 times as long as if I just came in here and said rigid group. What are the components? That guy, that guy, that guy, and that guy. I'll say okay. And now when I move that hinge panel, those screws move with it. Okay. Now I'm going to undo that. So be careful because let me make sure I undo rigid group. When you're doing the rigid group, don't select all of the screws at the same time, because now if I do this, you can kind of see how all 6 of those screws are rotating at the same time, right? So obviously I want 3 and 3. So um, make sure you're selecting the rigid group that makes sense. So I'm going to do that as a rigid group. I'm going to do this as a rigid group. And now those move together and those move together. But you can see how quickly I was able to, create and simulate how this hinge works. I didn't even have to model the hinge. I brought it in from GrabCAD and was able to create as-built joints to simulate how the leaves work together. And then I was able to use rigid groups to simulate how the screws stay on those leaves. Okay, moving on. Here's a kind of a fun little example. There is a command in the assemble menu called tangent relationship. So this is like a joint, but it's not in the joint command. So here's the different motion types, rigid, slider, etc. So there's one in here kind of on its own called tangent relationship. And the preview or the thumbnail kind of gives you an example of what it does. It allows you to pick a face on one component and a set of connected faces on another component, and they have to stay tangent with each other. And a cam is a really good example. So if I grab this guy and rotate it, you can kind of see what's happening as I rotate this cam. So all of these basically pistons have a curved face on the bottom of them. And then this is a solid component, and basically a camshaft. And as I'm rotating this gear, all of these have tangent relationships to the cam. So as I'm rotating this, they have to stay touching. And it basically, and you can see all of the slider joint types. So all of these slide up and down. And that's what pushes the dolphin pieces up and down. This is like a 3D printed kind of a thing. So if I expand this open, you'll notice this relationships, and you can see all of these different tangent relationships. So I'm going to go ahead and delete this last one here. So if I were to rotate that, you can see this last one's not doing anything. Okay. So all I have to do is come in here and say tangent relationship, and all it's asking for is component 1 and component 2. So I'm going to come over here and I'm going to grab this curved surface right here as component 1, and then component 2 will be this one. Now this cam is round, but if it was like teardrop shaped or whatever, I could select multiple faces of that teardrop shape. And so I would select that, say okay. And now when we rotate that, you can see how that surface has to stay tangent to that cam as it's going around. So that's what the tangent relationship does for you. Kind of a fun example. Used a lot, mostly in, for example, like cam simulations, etc.
Hey Brad, really quickly, can this
Yeah.
potentially be applied? So, Richard had a question here regarding creating some sort of a timbre joint. I feel like this might be fairly similar. Could you speak to that a little bit?
What kind of joint?
Like a timbre joint for roll top desktop.
Um, I guess I don't understand. I'd have to see an example of that. If
Absolutely.
Yeah. I apologize.
No, it's totally good. If you have, Richard, please let us know if you have something like a model or something, if you'd
Or
like to
even
send to
a
us.
web page you can point us
Yeah,
to or something like
we're
that
happy
that has a
to take a
picture.
look.
Yeah, I would take a look at it.
Thank you.
And is he specifically talking about the tangent relationship for that particular type of joint? I'm
I
assuming.
think it could be fairly similar. It's just a
Okay.
guess from my part, but
Yeah.
yeah.
Um, and actually, now that I'm thinking about it, if I think I know what it is, but I don't want to assume, there could, if make sure you join part three of the series because I am going to be talking about contact sets, and that could potentially solve the question you're asking, where you're trying to simulate how things could work in conjunction with other things. So, like for example, as you're pushing a table closed, do these little latches, close and all this kind of stuff. That's where contact sets really come into play, and we're going to be covering those in part three. So definitely make sure you sign up for part three. Little plug there. Okay, duplicate joints. This is fairly new in the assemble menu. Duplicate with joints. So here I already have a component, and you'll notice when I slide this back and forth, this is like an air brake for a missile or something like that. And I already have some joints created, but I want this component to go to, two other locations. And if I were to just pattern this thing, it wouldn't pattern the joints, and I would actually have to recreate the joints and all kind of stuff. So they've recently added this duplicate with joints. Now, it's pretty powerful, but you still have to kind of pay attention to what's going on. So let me show you what I mean by that. So I'm going to say duplicate with joints, and it's asking what component do you want to duplicate? So this guy, and you'll notice it recognized, okay, that component has two cylindrical joints associated with it. But then you'll notice it says select a snap point. And what it's asking for is select a snap point to where it's going. Now, unfortunately, it just says cylindrical 20 and cylindrical 21. Well, which one's 20? Which one's 21? If this is 21 and I pick it to go over here, obviously that's going to be wrong, right? So a little tip that I recommend is I'm going to expand open my joints, and you can see right now it's highlighted cylindrical 21. And if I come over here and turn on or off cylindrical 21, I can see that that's this joint right here. Okay, so I know that I need to be picking over here and not over here, and hopefully that makes sense. So this is in the center of that control rod. So I'm going to come over here and grab the center of this control rod. And sure enough, you can kind of see it creates a copy of that. And you can see it says one instance. Now it also says select a snap point for cylindrical 20. It needs to know where does that need to go. So I'm going to click here. I'm going to kind of zoom up in here a little bit, and I'm going to grab the center of this gray part here. So it's kind of hard to see. If I rotate sideways, you can kind of see there's a start, a middle, and an end of that cylinder. Okay, so I'm basically grabbing, if I look at it kind of down this way, there's a start, a middle, and an end. So I'm grabbing the middle there. Now, here's what I was talking about. Notice I get a really weird result and I get a warning message. There's these three little dots right here. And if I click on that, there's these little swap arrows or flip direction. So I'm going to click that swap direction, and now it goes in the correct direction. Hopefully, I'm going to move that just in case you didn't see it. But I click on these three little dots right here, and then there was this little flip direction. So if you get a weird result, just click on that. I'll say OK. And now when I grab this, sure enough, we can see that that component was copied and the joints were copied. I didn't have to recreate the cylindrical joints and all that kind of stuff. I just had to say, hey, here's where they were, here's where you need to go. So it's, it does 80% of the work. I had to do about 20% of the work. So it just copies those joints for me automatically, which is kind of nice. Okay. Man, time's flying. I hope this is making sense. Again, I'm just kind of hitting high level on a lot of these different commands. So we've done joints, we've done duplicate with joints, we've done as-built joints, we've talked about rigid groups, we've talked about tangent relationships. Um, the next thing I want to talk about is driving joints and motion links. So I'm going to come over here, and here's a little like a vise assembly. And if I grab this handle and rotate, you'll notice, let me lock this guy down really quick. Let me lock that motion. If I rotate, you can see that I have a revolute joint, and then I also have a slider joint. And this assembly is actually showing two different things. It's showing motion link, and then we're also going to talk about driving joints. Okay. So I've linked these two different joint types together. So I've linked the rotational joint with the slider joint. So we're going to talk about that here in a second. But then I also can do what's called drive joints. So I'm going to say drive joints. And I'm going to click on the slider joint. I can see the icon right here. I'm going to click on that, and you can see I can just type in a number. So I could say 1 inch, for example, and it forces that slider joint to move exactly 1 inch. Okay, let's do that again. I'll say drive joint. I'll click on that, and I'll say go 0.25, and it moved exactly 1/4 of an inch. I could click on the revolute joint, and you can see right now it's at minus 286.3 degrees. I could say go to 0 degrees, and now it's at 0. I could say go to 45 degrees, and now it's at 45 degrees. So you can drive the joints very specifically. And I'm pointing this out because a lot of times you see, people just, dragging on the joint or rotating the handle or something like that to kind of simulate the movement. But you might want to be very specific on how far something moves or how far something rotates or whatever. You can use the drive joint command to do that. Okay. And I'm going to show a really cool trick in session 3, where we combine these contact sets with the drive joints to get exact measurements, like how far can this thing actually close and open. So you can see how it actually stops. And there's a reason for that. It's not because of a joint limit, it's because of a contact set. Um, so you can see how it goes a certain distance. And that's actually using the contact sets and the drive limits. So here's another example of that. I'm going to go ahead and unlock this motion here. And I could come in and say drive this angle joint here and say I want that to be set to 45 degrees. And now this vise is rotated to be 45 degrees. And I could create a drawing of this, right? In this situation, and I know that that is at 45 degrees. Or I could set that to be any angle that I want that to be. Drive joint. Oops, it locked it back up. Give me a second here because I said undo. um, I'll go ahead and say drive joints. Let's set that to be, 30 degrees. And now that's set to like 30 degrees, for example, or 60 degrees, whatever you want that to be. And you know that that's precise, right? So kind of a cool trick. Not a lot of people know about that, but that's what that drive joints allows you to do. Okay. And then I talked about motion links, where that is where we've linked two things together. So in this case, I've linked the slider joint with the rotational link there. If I go into my joints, you'll see this motion link. So I'm going to go ahead and delete it. And now if I rotate the handle, nothing happens. And if I grab the slider, nothing happens. Okay. So if I come in here and say motion link, it's asking for the two different joints. So I'm going to grab the slider joint and I'm going to click on the revolute joint. And you'll notice it gives me kind of a preview of what's happening here. So I'm going to go ahead and stop the animation. And then you can see it's listing the two different joints. And then you can see a distance. So what this is basically saying is for every rotation, for every 360 degrees that this rotates, the slider is going to move 0.394 inches. So for example, if I were to put a 0 in front of that and said, okay, I'm going to have to crank this handle quite a few times for that to move. So it's a very fine, measurement, for example. If I were to change that to 0.94, I barely have to rotate the handle and it's going to move quite a bit, right? So you have the ability to control what um, for every revolution, what's the distance that it needs to move. Now, here's a really neat example of this. So this is a 3D printed card shuffler. And when you rotate the handle, you'll notice the gears move, which ends up rotating these little shafts here that have some rubber grommets on it to grab the card. And it, brings the cards in and then they drop down. They, drop down into this middle area and they shuffle. So I've got revolute joints going on all of these gears and on the shafts and all that kind of stuff. I've got slider joints going on for the cards. And so there are motion links connecting all of those together. So here's a neat example. So I have a motion link connecting this revolute with that revolute right there. And I'll go ahead and just do this. It'll probably complain at me, but let me see if it'll let me do this. I'll say motion link, that guy, and that guy. Yeah, it says it already exists. Um, but it's basically asking for every rotation of this, how many rotations of this. And all I have to do is count like how many teeth are on each of these gears. So for example, like I'm just going to make up numbers because I don't want to sit here and count. But let's just say that's, 24 teeth. And let's just say this is 12 teeth or something like that. Um, and when you and won't let me do it because it's already created one or whatever. But that's how I created these is I counted the number of teeth, um, and then set those numbers in. So like again, let's say that was 24 and that was 12. So basically for every 24 degrees of this, it rotated 12 degrees of the other one, for example. And it creates those motion links for me. So and then I just motion linked the slider to the revolute. And so for every revolute, every 360 degrees, this moves a certain distance or whatever. But you can kind of see how you can create some more complex assemblies with using motion links. Okay, last thing. Now that we kind of know all of the commands, here's a vise with a whole bunch of individual components. Okay, and I want to use this in my design, but I want it to work correctly. So, I brought this in from like GrabCAD, for example. It came in fully assembled, but there's nothing linked together. So how quickly could I make this work? So I'm just going to click on this guy. I can see that's the base. I'm just going to go ahead and pin that in place so it no longer moves. I can see that, this moves individually. So I'm going to kind of group all those together. So let's just say rigid group. And I'm just going to select these screws and that whole unit like that, like so. And now that's all grouped together. Let me do the same thing over here. I'll say rigid group. These three screws, that guy and that guy. I'll say okay. And that's all grouped together. Looks like I need to maybe group those guys together. So let's do a rigid group of that to the base. Okay. Um, let's go ahead and do an as-built joint. It's a revolute. Let's do that guy with maybe this component here. And let's just revolve it around a circular edge. And now when I grab that, we can see that that moves around. Okay. Well, then I want to create an as-built joint. Let's do a slider. So I want this guy to slide along here somewhere. So I'm just going to grab an edge like that, say okay. And now that slides along that face. I'll do the same thing here. As-built joint, that guy and that guy slides along that edge. That slides like so. And then we can come in and say, let's create a motion link. So for when this revolves, I want this guy to move. And so as I rotate this, you can kind of see how that moves, but I want them both to move at the same time. So I'll go ahead and create another motion link and I'll say, I want to link that slider joint and that slider joint together. Let's go ahead and reverse those. And I want them to be the same number. So let's just do 2 and 2, for example. I'll say okay. And now if we rotate those, we can see that that vise closes at the same rate, like so. So literally in, looks like about 2 minutes, I was able to bring in a file from GrabCAD, and then add all of the joint types that I needed to simulate how this thing would work. And then next week, we'll talk about how to make it so it doesn't do this, right? We'll talk about joint limits. We'll talk about the contact sets, etc. So it'll actually physically stop and not allow it to clash with each other. But I can now use this in my design to, hold a particular component or whatever. And I didn't have to spend a ton of time creating all of these individual joints. So, okay.
Couple of
There,
questions there for you,
yeah,
Brad. Thanks for going through that super fast. So I
yeah.
think Neil asked about, so I think it was on that Vice that you had where you created a motion link. Uh,
hmm
so the question is, how does the actual joint know the pitch, meaning for one revolution, right? How does it know the distance the jaw needs to move? Is that something that we put in, or is that, I think you did mention that at one point.
I knew somebody was going to ask that. So gold star for whoever asked that. It doesn't know the pitch. It doesn't know like what this was or whatever. Um, if you know the pitch, you can enter that into the motion link. So if you know for every revolution it has to go this far, between the whatever the pitch of the thread is, you would enter that distance here. So, but Fusion doesn't know that this is a 0.394 pitched thread, for example. And I'll be honest, I don't know where it comes up with this number. So it just came up with that number. With the gears, I was trying to show that, and unfortunately, the card shuffler, it already has all of these joints, and I don't want to recreate them. But I basically count the number of teeth, and that's what you enter in for the motion link, is the number of teeth. And let me do this one here. Let's see if it has it. Yeah, so 31 and 22. So there's a 31 tooth gear and a 22 tooth gear, and that's Yeah, it's linking these two together, and that's what works for that gear ratio for that. And I wish it even said, because it says angle, which doesn't make a lot of sense, but it's the gear ratio, and that's what makes that work. So, but yeah, it isn't smart enough to understand the pitch of that thread for this. So, good question though. Any other questions, Amir, that came through?
Not that I'm seeing. I think Raul mentioned maybe something about tying down the lockdown bolts for, not sure if you're still in see in here, Raul, but I think it was, yeah, it was in your bench vise. It was
Okay.
the very first one.
Okay, so go in the bench
Yeah.
files. What was
Mhm.
the question?
It was something about not tying down the lockdown bolts to the rotating slider. Not particularly sure exactly which one you mean. If
I
you
see.
are in chat, just feel free to elaborate if you'd like. Um, and then is Tanner's asking, is there a way to make a tangent relationship between male and female thread surfaces so that the movement is accurate upon rotation?
Okay, so Tanner, that's a really good question. That's going to come up in part three when we talk about contact sets and enable all contact. I'll give you a little bit of tidbit. You do not want to enable all contact with threads. It'll bog your system down significantly because it's mathematically calculating live um, how things interact. I will give you guys, if you're willing to um, bear with me here, a quick preview. This is what you'll see. So this is, I'm going to say enable all contacts. I have no joints whatsoever in this example here. And you'll notice as I'm grabbing this green rod, nothing's happening. But as soon as it touches that red band, it's pulling that red band. So this is calculating live. And as I continue to drag, it's going to grab that other rod and continue. And so I can do stuff like this. But if I move too fast, it loses control, right? I've pulled that rod out because it mathematically it can't calculate fast enough. And this is a simple example. Think about threaded surfaces and threaded mating surfaces and all kind of stuff. So you wouldn't want to do something like that with threads. Now, other things like I worked with a customer, they do like reclining seats in airplanes. They use this situation for like seeing how the tracks move for the reclining seat. They'll use the contact sets for that. But um, you could try the tangent relationship. Yes, again, I wouldn't even use tangent relationships for threads. I'd have to play with that, but so but yeah, I'd be nervous with something as complicated as how many faces and there are on threads. So yes, Steve, thread pitch would be one divided by TPI of the screw. Yeah, good point. So, um, okay, I know we've gone a couple minutes over. Like Chase mentioned, please make sure you sign up for the third session. We're going to be talking about contact sets, motion studies, bills of materials, and bringing like multiple assemblies together, working with multiple assemblies and assembling those together. So make sure you sign up for that. And I wanted to thank you for attending. I know these are kind of like we're trying to cover as much as we can in an hour, and we still had to break it down into three parts. So hopefully this was beneficial for you, and see you on the next session. So thank you.
Thank you, everybody.